Hi, I'm James McGuire, and on today's eSpeaks, we're talking about a number of topics that all relate back to artificial intelligence and generative AI. We're looking at the major shift in the tech sector toward decentralized computing, including the big generational migration to multi-cloud. To discuss that, I'm joined by Lee Caswell, Senior Vice President of Product and Solutions Marketing at Nutanix. Lee, thrilled to have you with us today.
I'm delighted to be here, James.
Great, and then that is, by the way, that is your personal library in the background, isn't it?
It is. I'm a reader.
You read a lot of books.
I'm a reader, and there's even a guitar in the background. So there you go.
We're gonna have to get to the guitar at some point, Lee. I'm sorry, I didn't warn you about that. We're gonna have to play a little guitar today.
Terrific.
So before we get to my insightful questions, what is the brief elevator pitch for what Nutanix does? Obviously, it's a well-known company, but for those who don't know it as well, what does Nutanix do?
Yeah, Nutanix provides virtualized infrastructure. And so that allows you to run any application, even the highest performant applications, and we'll talk about AI in this, venue, and you can run them anywhere. And this becomes important as customers are realizing they have multiple clouds, for example, today, as well as on-prem and edge infrastructure. And so the ability to run that all together with one operating model, high value going forward.
All right, that makes perfect sense. So you've written this sentence, which I think is quite notable. You've said that, quote, AI will drive a decentralization of IT infrastructure as AI models become more distributed. So why will AI models become so distributed?
You know, what we're finding is there's actually relatively few companies that can afford to build what we call large language models, right? Those are naturally suited for the public cloud, right? 180 billion parameters, for example, right? And hordes of data scientists, right? Not every company can afford that. But what we're finding, right, is that those large language models are now being made available to enterprises across the world. And now those enterprises want to go and do two things. They want to basically customize them, introduce their own domain expertise, right? So it's specific to their industry. So that's a tuning model, right? They also want to make sure their data is protected and that their data, right, is now a core asset. And so that model all of a sudden looks like, hey, I'm going to go and customize that data, probably in a data center at some, at some place. And then finally, I want to go and run these, what we call inferencing. So there's a training model, and then your inferencing is actually running of the model. And so we're probably going to run that now closer to where the data is being ingested. So it could be a retail store, for example, right, where you're using generative AI to manage theft and shrink. Could be a manufacturing facility where you'd be looking at how you would do, let's say, maintenance procedures. So we see this as a natural distributed data problem and a real value for a common cloud platform across those different endpoints.
Well, it seems like one of the problems or one of the challenges there is going to be, is there going to be the processing power to crunch the data there in that distributed world? Is that going to be an issue?
It's a really hot topic right now, I'll tell you, right? So certainly, there's GPUs are being used like largely for this, and they're incredibly powerful, but also relatively expensive, and they use a lot of power too, right? So customers are really looking at, what do the models start to look like, right? Large language models in the public cloud. Now I've got smaller models, or compact models they're called, right? And so we're a really interesting debate right now around, hey, where do I need to have GPUs? Could I use CPUs, for example, right? And are CPUs going to have enough processing power? Are there different ways? This is a really interesting computer science, discussion right at the moment. What we're finding, right, is that AI is coming to every industry, and we're going to solve this as a way, basically on the economics of how to make it, feasible for every industry.
You mentioned large language models, and I would love to take a short detour because I think it's such a hot topic these days. I think the companies are struggling with, we know we need a large language model. Are we going to buy one off the shelf? Are we going to rent one? Are we going to make our own? It's also expensive. We don't really get it. But it seems like the large language model becomes this proprietary advantage. If you've got the bucks to make a good one, you can really get ahead in the world of AI. And any thoughts about that world, the challenge of today's large language models?
Well, I think the issue, right, is that, competitive advantage isn't created by doing the same thing that everybody else does.
Right.
That's rarely the case, right? And so just like you go and take your ERP system or CRM system, or right, what people have used in the past, you basically customize for your industry, right? So if you're a federal customer, right, and a dark site, you're going to be thinking about this differently than a healthcare provider right now. And you've got HIPAA requirements, for example, around where your data and how it's being used, right? Or in a retail environment, how you start thinking about, how do I make sure that the point of sale system I have today is also able and capable of running generative AI, right? So one of the big solves here is to think about, how do I find a platform, and ideally a cloud platform, right, that allows me to have consistent operations across these, but allows me to customize at the same time.
All right, that makes perfect sense. I want to get into the larger question about the virtualized enterprise IT infrastructure, but let's make sure we drill down into Nutanix. How is Nutanix addressing the AI and hybrid multi-cloud needs of its clients? What is the Nutanix advantage?
Well, we announced something called GPT in a box, right? And it's not literally a box, right? But the idea was that it's a prescriptive way to say, hey, you can get started today. What we found, right, is that only 10% of the customers we've surveyed, right, were actually going to build their own large language models. So they're going to take large language models and they want to get started. Hey, how do I get started customizing, right? So one of the things you can do here easily, right, is you can take standard servers. I talked a little bit about, the power of using standard server hardware. Now you can take servers with GPUs, very, fully certified by Nutanix, and you can build a GPU-enabled cluster. And we've got services that allow, us to help you now think about how to go and build the application. Now, a lot of the early applications, James, are basically chatbots, for example, right? To simplify customer service, for example, or a lot of video generative AI for things like I mentioned, managing shrink, for example. And so customers are looking at those and saying, hey, Nutanix becomes a trusted advisor to help you get an AI application going, and you can start small, right? That's a really interesting way to go and give you an option to go and get started today.
Well, that's pretty amazing. Let me make sure I fully understand. So you're calling it GPT in a box.
Yeah.
It's in a sense, it's sort of like, it sounds like it's a low code artificial intelligence development system.
It really is, right? So, the way this, the way Nutanix works, our cloud platform software aggregates standard servers together. Servers you can add GPUs to. Those are all qualified today from all of our major hardware partners. And then our software then takes AI as the next application. Turns out, like the way our software has been used in the past, virtual desktops was a big landing spot. Then people brought in databases and performance databases. Then they brought analytics like Splunk, for example. And now the latest application is AI. And so by adding GPUs and helping size and configure what your application would look like, we're helping customers get started saying AI is the next application you'd run on the Nutanix cloud platform.
So you use the example of a chatbot, which makes perfect sense. I'm thinking of this hypothetical customer sitting in front of the Nutanix GPT in a box. What else might they possibly build with that using AI?
Well, I gave the example of like maintenance monitoring. AI has been around a long time, right? I recall doing like locomotive automated maintenance, for example, right? A long time ago. And, but what's different right now is that AI, as proven by ChatGPT, is accessible to everyone. People see the power of it and how fast it is, right? So now what you might want to start looking at is, hey, can I go look at, for example, in a manufacturing environment and start looking at the output data that's coming from a manufacturing line and start looking at when predictive or preventive maintenance would have to be required. A lot of cost savings if I can do that intelligently, right? Or maybe I'm on a wind farm, right? Or in a retail environment, think about what point of sale data is coming in that makes me want to think about, hey, a different end cap display, and how can I go and present that? So there's just a tremendous amount of opportunity for applying the speed of AI into environments of all sizes.
Yeah, you talked about Nutanix enabling this virtualized IT infrastructure in a cloud environment. It seems like a huge need for that. How does that technology relate to something like AI ops, which is artificial intelligence trying to run the entire IT infrastructure? Is there overlap between those two worlds, or what's the combination or difference?
Yeah, a little bit. So, I think of AI ops, right, which is operational, basically being automated and predictive, improvements, right? Pretty interesting to think about. I'm talking futures here right now, right? You
Go
can
ahead.
start thinking about, now that you have a hybrid multi-cloud, which now you start thinking, hey, I've got multiple clouds, I've got my data center, I've got my edge. Start thinking, how do I optimally locate applications and data over time?
Mm-hmm.
And you might think of, I think of there are four key areas where you might think of it for cost. A lot of focus on cost these days, right? Around the cloud was very agile, but pretty expensive, right? So I might relocate for cost. How about performance? It turns out like modern users are extremely sensitive to performance. In fact, the fastest you do something becomes the standard by which every other interaction is measured, right? And
Right.
then you've got data sovereignty, of course, right? And one last one I'll introduce is sustainability. You might start thinking about how to go and locate applications and data based on the power and cost, right, of that power, and also sustainable goals, right, that you have. And so there's a really interesting opportunity of automating this in the background, making recommendations, and then being able to have the ability to basically derive these and place these optimally across the hybrid multi-cloud environment.
A really interesting idea, because I sometimes hear like, oh, the myth of application portability. In theory, one could move it between hyperscalers, but you really can't. The new boss is the same as the old boss, and just you're stuck once you have your. But you're saying that this theoretical AI system is going to move this heavy duty application perhaps
Yeah.
between hyperscalers.
Here's what's available today, right? Always look at the standards that become available that make portability possible. Like TCP/IP, right, became a really big thing for being able to move, like from a network standpoint. There are two standards now to watch carefully. One is Kubernetes. You'll hear about Kubernetes, over, and people are like, well, what is it? Well, it's really a way to orchestrate these new, what we call containers. The new applications are based on containers because you can develop them more quickly. You can place them right across different environments more quickly. So Kubernetes is now a standard for portability for applications.
Right.
Right. So now I can move applications more. And so this is really interesting. Enterprises have standardized on Kubernetes, different development environments, right? But Kubernetes is a standard for portability of applications. Similarly, there's a standard for portability of data, and it's called S3. And so S3 compatible data can now be floating. So we're going to basically free ride, right? Look for how you can use these new standards to make applications and their associated data more portable, right, across the hybrid cloud. Nutanix can help with that.
All righty. Well, let's look to the future. I mean, that's there's massive amounts of money out there. So, Lee, tell us where is it all going, and where can we put all our money? I mean, the future of AI and hybrid multi-cloud, that probably is about a 4-hour question. If you did address it in just a short amount of time, what are some key milestones you think you might see in the years ahead?
Well, I think everyone is wrestling with predictability and how to go and forecast the future, right? It's an unpredictable world right now, right?
Right.
Economic changes all over, right? You've got global geopolitical events, and you start thinking about skill shortage as well, right? And
Right.
so what we start to look at is customers are looking for how do they apply their scarce skills in new creative areas and stop doing things that were actually less value. And so what I see us doing forward is everyone acknowledges, right, this is going to be a multi-cloud world. You're going to have, resources across different clouds. The on-prem data center is not going away, right? And the edge is growing, right, where 50% of data is forecasted to be at the edge. So where does it go? I think what happens, right, is you start thinking, how can I get this portability platform in place and tap into the power of servers, right? So a server-based architecture gives you the flexibility to have the degrees of freedom you're likely to exercise over time without locking you into deciding today.
Well, I think about the future. There's this future image where we almost leave servers behind. They're a commoditized component of it all, but we're going to stop thinking about servers in the future, are we not?
I think so, right? And one of the advantages, right, is it used to be that you'd buy this big refrigerator sort of thing and plug it in, and it was there for the next 5 years, right? And
right.
But there was a great risk that you bought the wrong thing, so people tended to buy a lot of it, right? And now with server-based things, it's like, hey, these are like chiclets, right? I can basically bring these in small increments. I can scale really seamlessly and easily. New technology comes seamlessly integrated into these, right? So I don't have to worry that I bought the wrong thing. You can always scale and basically build out of that. That's a huge solve for customers who are worried that, hey, I know I need to invest, but I want to make sure that I bought the right thing and I can scale over time.
That makes sense. In closing, I'd like to share with you sometimes a doubt I have about the future of enterprise IT. I think sometimes in my less optimistic moments, I think we're almost going to collapse based on the total complexity of it all. We're not going to be able to hear it. It's all going to be so complex. The system is going to collapse under the weight of its own complexity. I guess the answer, I mean, the idea of a virtualized infrastructure that can span clouds and the edge is an optimistic view. It almost makes it all attainable. But I still sometimes think, the level of complexities is in a hockey stick moment. I'm not sure that we humans are totally equipped to handle that all. Thoughts about that very broad idea?
Well, you can look at phones as an example, right? Like phones and all the new technologies that came into a phone, right? So now, like, I don't have to have a separate flashlight, for example, or a separate compass, right? Or a separate atlas, right? I mean, all of those things got in. But there is, by the way, a learning curve, right? You can see this, right? As folks, trying to make sure that they can actually, take advantage of all the capabilities. But what happens is once you get to a standard platform that you become comfortable with, now all of a sudden it becomes easier to assimilate net new things into that platform, particularly as it rides right across, in our world, right across multiple clouds. And that's a big solve, because otherwise what happens is you have to learn every cloud independently. You've got to learn every on-prem technology. And like you said, you basically run out of cycles, right? So, basically standardize on the parts that you don't want to spend time on, and then you can focus on the new things.
Well, I hope that vision comes to pass. That is a positive vision. Lee, you've said it. I've learned a lot. Thank you so much for sharing your expertise today. And please come back and talk with us again sometime.
James, always a pleasure. Thank you so much.